Good morning, children. How are you, children? I think you are fine. Okay, children. Are you remember last class? What we learned? Yes, you are right. We are learning frictional force and static friction. Now today we are discussing about activity 2. Activity 2. What is activity 2? Observing the variation of friction. So observe the figure 6. What you observe is a boy trying to move the box. Yes, push a box which is kept on the floor with a small force to move horizontally as shown figure 6. But the box does not move because there is a frictional force which is equal and opposite to the applied force on the box. Applied force on the box. You observe this one. Now gradually increases the applied force. The box still does not move because the frictional force also increases accordingly, and thus the balance is the increased applied force. From this experience, what we concluded is we concluded that static friction is a self-adjusting force. Which is the self-adjusting force? Is static friction is the self-adjusting force. Then, but there is a limit to the static friction. As you keep and increasing the applied force, at some point the box starts moving. That is when the applied force is more than the limit of the static friction. The body starts to move as shown figure 8. Now activity 3. Activity 3. Factors affecting friction. Effect of roughness on frictional force. Children, do you observe figure 9? What are you observing? Yes, there is an inclined plane and set a marble at a point. Okay, now listen. Set up an inclined plane on the horizontal floor. Use a wooden board as a inclined plane. Put a mark at any point A on the inclined plane. Now let a pencil cell or a ball move down from this point. Note the distance covered by the pencil cell from the bottom of the inclined plane to point where it comes to stop. Now spread a cloth over the floor. Make sure that there are no wrinkles in the cloth. Try again above the activity. Now measure and note down the distance. What are your observations from this experiment? In which case is the distance covered maximum? In which case the distance covered minimum? Why? Is the distance covered by the pencil cell different on different surfaces? Discuss the result. If you do the above activity by replacing the cloth with white marble surfaces or glass surfaces, can you predict that distance covered by the pencil cell? Yes, you can concluded that smoothness, roughness of the surfaces of both the floor and the pencil cell could affect the distance travelled by it. Generally, many surfaces look like perfect planes, but there exist a many ups and down on them. So then friction is caused by the irregularities on the two surfaces which are in contact. Irregularities on the two surfaces lock into one another on the two surfaces lock into one another when we attempt to move on any surfaces. We have to apply a force to overcome interlocking. On rough surfaces, there exists a large number of irregularities, that means up and downs. Hence, the force of friction is greater if a rough surfaces is involved. Children, are you understand what we learning from this class? We are learning factors affecting friction and observing the variation of friction. From last class what we learn? From last class we are learning static friction and frictional force. Children, last one find out static friction is a adjusting force. Static friction is a self adjusting force. Okay children, are you understand? I think you understand very perfectly. Thank you children. Tomorrow we will continue activity 4.